Okay, so in this lesson, we're going to discuss simplifying radicals containing variables, and this will be part one. So part one is a little bit easier type of problems, and then we're going to look at part two in the next situation. But this will be part one, and so again, we're going to look at simplifying radicals containing variables. Now, as a review, let's remind ourselves about something we've learned in a previous lesson. So if I asked you to simplify this radical expression, we have 49, the square root of 49 times x to the 8th times y to the 18th. All right, so remember what we did. So in that situation, we asked ourselves, what's the square root of 49? So I'm going to, in our mind, we looked at the square root of 49. So the square root of 49 is what number? So remember, what times itself is 49. That was the idea, right? So what times itself is 49? Well, 7 times 7. So that means the square root of 49 is 7. So we said 7. Then we looked at the square root of x to the 8th. So the square root of x to the 8th. Well, the square root of x to the 8th is equal to what? Well, what times itself is x to the 8th? So remember, when you multiply like bases, you add exponents. So we saw that was x to the 4th. And remember, when we had that discussion, we said this. If you want to find out what these exponents are, all you do is just take 8 right here. And there's your, remember your index, so there's no index there. It's understood to be 2. So that's why we set square root. And you divide by 2. So 8 divided by 2 is 4. And so that's why you see those here. X to the 4th times x to the 4th is x to the 8th. And so this became x to the 4th. Then we did the same thing with the square root of y to the 18th. So if we go here and do that, so 18 divided by 2, the index is 2, so that's 9, right? So we knew that when the two expressions here, so an expression times itself is y to the 18th, then that would have to be y to the 9th, because y to the 9th times itself is y to the 18th. When you multiply like bases, you add exponents. And so if you look at this, and so remember, I'm taking the square root of this radicand, so that's the answer here. So again, that makes sense because if I take this right here, 7x to the 4th, y to the 9th, and multiplied by itself, I get the radicand. Because look, 7 times 7 is 49. X to the 4th times x to the 4th is x to the 8th. Y to the 9th times y to the 9th is y to the 18th. Okay? So that's why that's the answer. Now again, we're assuming that all these variables represent positive numbers. So we don't have to worry about absolute value any further. We're done with that idea. Okay, so now that's what we did in the previous lesson. So notice that this when I simplified the square root, I didn't have any square roots left in the answer. You see there was no square roots in the answer, right? Okay. Now we're going to get to the situation where that's going to change. All right, so let's look at this example. We're going to start with a very simple example. So number one, we're going to say simplify each of the following. All right, and then we're going to assume that all variables represent positive numbers. So we don't have to worry about that absolute value. Okay, so number one, we have x, the square root of x to the 9th power. Okay? Now, when we did, I want you to notice this. If you go back to the lessons that dealt with the previous lessons, and you look at the exponent of the variables, do you notice that all those exponents were even? Every single exponent was even. So if you go back to that previous lesson that was called, and it was in part of another topic, but simplify radicals containing variables, and that was part one of another lesson. But notice that all of these exponents, if you look at all the variables, all of them were even. See that? Oops. For square roots, we're dealing with square roots. I'm going to skip the cube root for right now. So if I go only with the square roots, see, all those were even. See that? Even. Here's another one with a square root. All those exponents were even. See that? Now we're getting to a situation where the exponents are odd. So what do I do if the exponent's odd? So that's the question that we've got to focus on. What happens if the exponent is odd? Okay, so here's what you got to do. So do you see that the index is 2, right? Okay, so the index is 2. If the index is 2 and your exponent is greater or equal to 2, so if your exponent is greater or equal to 2, you can simplify this further. So I'm going to write this out. So a radical expression, and let's go ahead and, well, I'm going to go ahead and just use radical expression. So a radical expression is simplified. So a radical expression is simplified if the exponent of the variable is less than the index. Okay? Now, when I say radical expression, I'm only talking about a radical expression in the variables. Just looking at the variables, okay? All right, so a radical expression with variables, is simplified if the exponent of the variable is less than the index. So is 9 less than 2? The answer is no. Okay, so I can simplify this further. Now here's how you want to simplify it. The best way to simplify is this. Okay, listen carefully. You want to rewrite x to the ninth. You remember you can rewrite x to the ninth in multiple ways, right? You can say x to the second times x to the seventh. Y'all agree? Okay, because when you multiply like base, you add exponents. You also know that you can rewrite x to the ninth as, let's say, x to the fifth times x to the fourth, right? Those are all different ways of rewriting x to the ninth. You also agree you can rewrite x to the ninth as x to the second times x to the third times x to the fourth, couldn't you? Because when you multiply like bases, you add exponents. 2 plus 3 is 5, 5 plus 4 is 9. So those are all multiple ways of writing x to the ninth. Okay? What you want to do here, though, when simplifying the square root of x to the ninth, you want to rewrite it using this idea here. But you want to make things so much easier on yourself. And remember, we're only dealing with square roots here. The index is 2. You want to use the largest, when you rewrite it, you want to rewrite it so that way, you want to rewrite it, x to the ninth, so that you want to rewrite in two, as a product of two factors of x. You want the first exponent to be the largest even number. See, 2 is even, right? The index is even. The largest even number less than 9. What's the largest even number less than 9? 8. So that becomes x to the 8th times x. Y'all agree that's also one of the things I could have listed here, x to the 8th times x? And so that's what you're going to write here. So this will become the square root of x to the 8th times x. So again, let me mention it again. You want to use, when simplifying a square root of a variable raised to a power, I can simplify this further because the exponent is greater than or equal to the index. So if the exponent is less than the index, I cannot simplify it further. Okay? So whenever you simplify this, so this can be simplified, whenever you rewrite, so it's always a good idea to actually do this, rewrite it. Rewrite it so that way the product, you're using the largest even exponent that is less than what you see here. So this is a 9. The largest even number less than 9 is 8. So this becomes x to the 8th times x. And now I'm going to use the product rule. So remember the product rule? Okay, so the product rule, remember, said this, that we learned in the previous lesson. So if I have the product, if I'm taking the square root of a product of factors, they can rewrite this as the product of the square root of each of those factors. So what that means is this. I can rewrite this as the square root of x to the 8th times the square root of x. Okay? And I should have left some room here, so I'm going to just go further down here. And so now we know this. From a previous lesson, let's look at the square root of 8, the square root of x to the 8th. So the square root of x to the 8th is equal to what? So what times itself is x to the 8th? Well, what's 8 divided by 2? 4. So it's x to the 4th times x to the 4th. So x to the 8th is x to the 4th. Can I simplify the square root of x? No. Why not? Remember, a radical expression, and we're only talking about with variables, is simplified if the exponent of the variable is less than the index. So what's the exponent here? X to the first, so the exponent is 1. 1's less than 2, so I cannot simplify that further. So that's your answer. Now let me say this. We tend to put the square root at the end. So put x to the 4th in the front and the square root of x at the end. Okay, so there's the answer. All right? Okay, so let's do another one, and then hopefully the discussion will connect a little bit better with you. So let's look at number 2. So number 2, let's suppose I had y to the 13th. Let's do number 2, y to the 13th. The square root of y to the 13th. Okay, so here's my question. First of all, can I simplify this further? Yes, because the exponent is greater than or equal to the index. All right, so I can simplify that further. So the index is 2. This is 2 or bigger. So I can simplify it. And so when you simplify this, you want to rewrite it so that way you can you can simplify one of these parts. So what's the largest? Remember, this is even. This is 2. So what's the largest exponent? What's the largest exponent? The largest number less than 13 that's even. The answer is 12. So this is going to be 12, and this is going to be 1 right here, y to the first. And so now I'm going to use the product rule. So it'll be the square root of y to the 12th times the square root of y. And then the square root of y to the 12th is what times itself twice is y to the 12th? Well, y to the 6th. Square root of y. And so there's your answer. And again, always put the square root at the end. Now again, always make sure that this is simplified. So remember, check the exponent. The index is 2, the exponent is 1. 1's less than 2. You're done. Okay? All right, now let me say this. You may say, well, what if I didn't use the largest exponent? Okay, well, just like when you didn't use the largest perfect square in previous lessons, you have to do more work. So what if you didn't use the largest? So what if, let's say you said, well, I'm going to use y to the 8th times y to the, and then 8 plus 5 is 13, right? Okay, well, let's see what happens. So by the product rule, I would get the square root of y to the 8th times the square root of y to the 5th, correct? And the square root of y to the 8th, well, I know that's going to be easy now because y to the 4th times itself is y to the 8th. And so I get y to the 4th times the square root of y to the 5th. Now, you got to ask yourself, can I simplify this further? Yes, I can simplify that further. And the reason I can simplify that further is because the exponent, in order for it to be simplified, the exponent of the variable has to be less than the index. So, and it's not here. So then you got to think about, all right, well, how can I rewrite y to the 4th? Well, let's use 4. Because the largest exponent the largest number less than 5 that's even is 4. So that becomes y to the 4th times the square root of y to the 4th times y, right? And so now I can use the product rule again. So I get y to the 4th times the square root of y to the 4th times the square root of y. And then the square root of y to the 4th, what times itself twice is y to the 4th? Remember, I'm asking this. What times itself twice is y to the 4th? Well, y to the 2nd. So that goes here. So this is y to the 2nd. So I get y to the 4th times y to the 2nd times the square root of y. And then you got to deal with this now. When you multiply like bases, you add exponents, so 4 plus 2 is 6. So I get y to the 6th times the square root of y. So notice you get the same thing. But what's easier? It is so much easier if you use the largest number, the largest even number, because that's the index is 2, the largest even number that's less than 13, which is 12. See how much easier it is? Okay? All right, so from this point forward, we're going to use the largest. We're going to talk about the largest. Okay, number 3. Number 3, let's suppose you had the square root of 49 times x to the 13th. The square root of 49 times x to the 13th. All right, so again, do this in steps. Rationalize your thinking. So by the product rule, I know I can write this as the square root of 49 times the square root of x to the 13th, right? And since 49 is a perfect square, I know that that's going to be 7. So you got to simplify each of those radicals. So that's 7 right there. Now let's go off to the side and figure out what the square root of 13 is. And you don't have to. You could do it here if you want to. It does not matter. So if you do it here, you'd say, all right, I can simplify this further because that exponent is greater than or equal to 2. So let's think about what's the largest number less than 13 that's divisible by 2, and that's 12. So I can rewrite this as the square root of x to the 12th times x, because when you multiply like bases, you add exponents. 12 plus 1 is 13. So this is still the same thing as this. And now I'm going to use the product rule again. So the product rule, I get 7 times the square root of x to the 12th times the square root of x, right? And so can I simplify any of these any further? Which ones? This one right here. Can I simplify this? No. Why not? Because the exponent is less than the index. But I can simplify this because 12 is greater than or equal to 2. So the square root of x to the 12th, remember what times itself is x to the 12th? X to the 6th. So I get 7 x to the 6th square root of x. And there's your answer. Okay? Not that difficult, right? Just knowing some things from the past does help you. All right, number 4. Let's suppose in number 4 I had this, the square root of 81 b to the 11th. The square root of 81b to the 11th. All right, again, same idea, right? Let's use the product rule. So I'm going to rewrite this as the square root of 81 times the square root of b to the 11th. Can I simplify anything? Yes, 81 is a perfect square. So that means that the square root of 81 is 9. Now b to the 11th, can I simplify this? Yes, because 11 is greater than or equal to 2. So think about what's the largest even number. The largest even number, see 2 is even. The largest even number less than 11 that's divisible by 2. Well, 10. So that's going to be the square root of b to the 10th times b, right? Because when you multiply like bases, add exponents. 10 plus 1 is 11. And now use the product rule on here again. So you use the product rule here, you can use the product rule again. So I get 9 times the square root of b to the 10th times the square root of b. You'll agree? And then what's the square root of b to the 10th? So what times itself twice is b to the 10th? B to the 5th. 10 divided by 2 is 5. So I get 9 times b to the 5th times the square root of b. Can I simplify the square root of b? No, because the exponent's 1, 1's less than 2. So you're done. All right? So see, not that difficult, right? All right, let's look at number 5. Number 5, we have this. Number 5, we have the square root of 96 x to the 8th. The square root of 96 x to the 8th. Okay, so again, using the product rule, I get the square root of 96 times the square root of x to the 8th. Okay? Can I simplify the square root of 96? Well, yeah, I can, but keep in mind that 96 is not a perfect square, right? 96 is not a perfect square. So what you want to do is see if you can simplify the square root of 96. So let me just go right here and think about this. So 96, which of these perfect squares will go into 96? And you want to use the largest if you can find it very easily. So remember, 1 goes into all of them, so we're not going to talk about 1. So let's look at 4 first. 96 divided by 4 is 24. So 96 is divisible by 4, so I get 4 times 24. But the question is, was 4 the largest? Well, let's look at 24. Is there still another perfect square that goes into 24 evenly? Yeah, 4. So y'all agree that this 24 is 4 times 6? And so therefore, the square root of 96, rather 96, is 4 times 4 times 6. So if 4 is a perfect square and 4 is a perfect square, then that means our product, 16, is also a perfect square. And there is no perfect square other than one that goes into 6, so 16 is the largest. So I'm going to use 16. So I'm going to rewrite this right here. I'm going to rewrite this as the square root of 16 times 6. Okay? Now look at square root of x to the 8th. Can I simplify the square root of x to the 8th? Yes. Why can you simplify the square root of x to the 8th? Because the exponent is greater than or equal to the index. So 8 is greater than or equal to 2. So I could not simplify it if the exponent was less than the index. Okay? But this is an easy one because that exponent's even. So what's the square root of x to the 8? If it's even, remember we're dealing with square roots. If it's even, then that's the easy type. If it's odd, then I got to do some work. Okay? So 8 divided by 2 is 4, so I get x to the 4th. It makes sense because x to the 4th times x to the 4th is x to the 8th. Now I got to use a product rule on here. So I get the square root of 16 times the square root of 6 times x to the 4th. Y'all agree? Okay. Can I simplify the square root of 16? Yes. Can I simplify the square root of 6? No. So I get 4 square root of 6 times x squared. All right, now let me just say how to write the answer. And you're done with this in terms of simplifying. Okay, so mathematically, this is correct. You can write it like this. But we tend, let me just say this, we tend to always put the square root on the end. So I'm going to rewrite this as 4x squared times the square root of 6. But either one is fine, does not matter, okay? Does not matter. So if you want to put the numbers in the front and the variables in the back, that's okay. But sometimes you'll see it written like this. It does not matter. Just remember there are different ways of writing your answer because remember multiplication is commutative. The order in which you multiply does not matter. Okay? But for some people, for some individuals, they'll put the square root on the end so that way it doesn't look like this is underneath the square root. So that's the only reason why we sometimes we'll ask you to put in the end because some of you have a habit of putting it too close to the radical, this variable, where it looks like it's underneath and it's not supposed to be part of the radicand. Okay, the only radicand is 6. All right, so you see how I wrote it a little bit further away? Okay, so 4 times the square root is 6 times x squared. All right, number 6. Number 6, let's suppose we had the square root of 40 y to the 12th. 40 y to the 12th. So it's kind of like number 5, right? So I'm going to use the product rule. So I'm going to get the square root of 40 times the square root of y to the 12th. So let's look at the square root of 40. So 40 is not a perfect square, but is there a perfect square that goes into 40? Well, yeah, there's like the perfect square of 4 goes into 40. So I know that 40 is 4 times 10. And is there a perfect square other than one that goes into 10? No. So therefore 4 is the largest. So I'm going to rewrite this as the square root of 4 times 10, right? And notice the easy kind, when you're dealing with square roots, the easy kind is where the exponent is even. The exponent is even. So 12 divided by 2 is 6. So what's the square root of y to the 12th? Y to the 6th. Because y to the 6th times y to the 6th is y to the 12th. And now let's rewrite this using the product rule. So I get the square root of 4 times the square root of 10 times y to the 6th. And can I simplify any of these? Yes. Which one? This one. Square root of 4. Can I simplify the square root of 10? No. So I'm going to get 2 square root of 10 times y to the 6th. All right. And if you want to, you can put the square root of 10 on the end. It does not matter. So I get 2 y to the 6th. Square root of 10 if that's what you want to do. It does not matter, okay? All right. So that's all you do with these. All right. So again, the easy kind, when you're dealing with variables, the easy kind is where, and remember these are square roots, so the easy kind is where the exponent is even. Number 7. All right. Let's suppose we have the square root of, let's say, 50 x to the ninth. The square root of 50 x to the ninth. Okay? All right, so using the product rule, I get the square root of 50 times the square root of x to the ninth. And so 50 is not a perfect square, but is there a perfect square that goes into 50 besides 1? Yeah, 25. So I know I can rewrite this as the square root of 25 times 2, right? Now, notice, see number 5 and 6, the variable part in 5 and 6 were easy. Why were those easy? Because the exponent was even. And so all you did was just say a divided by 2 is 4. And it works because x to the 4th times x to the 4th is x to the 8th. But here, notice though, the exponent's not even. The exponent is odd. So you got to go back to what we saw earlier when we did situations like these. And I should not have used x to the 9th because I already have an x to the 9th here. So let me just change it. Let's just say this was x to the 19th. X to the 19th. All right, use x to the 19th. Okay, so let's talk about x to the 19th. So let's rewrite this now. So what's the largest number less than 19 that's even? And you want to use it because the index is 2. 18, right? So that becomes the square root of x to the 18th times x. And so now I'm going to use a product rule in here. I'm going to use a product rule in here. So watch what happens. So I get the square root of 25 times the square root of 2 times the square root of x to the 18th times the square root of x. Okay? Can it simplify the square root of 25? Yes, that's 5. Can it simplify the square root of 2? Nope, I'm going to leave it as square root of 2. What's the square root of x to the 18th? Now 18 is even. 18 divided by 2 is x to the 9th. And then I cannot simplify the square root of x. Now here's how you're going to write the answer. Listen carefully. Don't leave it like that. Because remember using the idea of that product rule, what's the square root of 2 times the square root of x? The square root of 2 times the square root of x, remember, it's just the square root of 2x, right? Okay. So you're going to say, and that's why we tend to put the radical in the end, because sometimes it does contain a variable. So the answer is going to be 5x to the 9th times the square root of 2x. Okay? So that's what we get. So 5x to the 9th, and then always put the square roots as one square root using the product rule. So using a product rule. So the reverse of that product rule. Okay? All right. So let's look at one more like number 7, and then we're going to look at another type of problem. So this is going to be number 8. So let's suppose in number 8, I have this in number 8. So let's say I have the square root of 200 y to the 23rd power. So 200 y to the 23rd power. Okay, so first of all, you're going to use the product rule to rewrite this. So it'll be the square root of 200 times the square root of y to the 23rd. And so let's deal with the square root of 200. So what's the largest perfect square that goes into 200? Okay, 100. So I can rewrite this as a square root of 100 times 2, right? And see, this is odd, so I got to do some work. I have to do some work. So what's the largest number less than 23 that's even? 22. So that means I can write this as y to the 22nd times y. Because when you multiply like bases, you add exponents. 22 plus 1 is 23. Now I'm going to use the product rule again on these two. So I get the square root of 100 times the square root of 2 times the square root of y to the 22nd times the square root of y. And so see, I have these 4 factors here. Can I simplify the square root of 100? Yes, because 100 is a perfect square, so the square root of 100 is 10. I cannot simplify the square root of 2 any further. Can I simplify the square root of y to the 22nd? Yes, 22 is even, so 22 divided by 2 is 11, so that's y to the 11th. And then can I simplify the square root of y? No, because the exponent is less than the index. And now let's write it better. So you need to always, don't leave it like this. You need to always multiply these square roots and write it as 1. So remember, the square root of 2 times the square root of y using a product rule is the square root of 2y. And so I get 10 y to the 11th times the square root of 2y. And again, always, whenever your radical in your answer has a variable, always put it at the end. You don't have to. So I'm just saying, remember, multiplication is commutative. That's normally what's written. But some instructors, some teachers will tell you just put the radical in the middle, which it does not matter. So they'll say you can write it like this, which mathematically is correct, but this is the one that we tend to do. Okay. All right. So that was number 8. Okay. Now let's look at number 9. Number 9. Let's suppose we had this. We had the square root of 12 to the 12 divided by m to the 4th. All right. Now what rule are we going to use here? Do you remember rule from the previous lessons that we talked about? So yeah, you're going to use the quotient rule. The quotient rule, because I'm taking the square root of a fraction. So according to the quotient rule, I can rewrite this as the square root of 12 divided by the square root of m to the 4th. And so I think about the square root of 12. Well, the square root of 12, what perfect square goes into 12? Let's see if I can simplify this. Okay, 4, so it'll be the square root of 4 times 3, right? And according to the product rule, I can rewrite this as square root of 4 times the square root of 3. And then what's the square root of 4? 2, so you got 2 square root of 3. So that's the numerator, 2 square root of 3. The denominator, I have the square root of m to the 4th. Okay, well, the exponent's even, so that's the easy kind. So what's the square root of m to the 4th? 4 divided by 2 is 2, so m squared. And it kind of makes sense because m squared times m squared is m to the 4th, the radicand. So there's your answer. You're done. Okay? So in this case, we have to go back to something we've talked about before, and that was a quotient rule. Okay, so let's go to number 10. Number 10, let's suppose we had this. We have the square root of 16x. I'm sorry, let's do this one. I'm sorry. The square root of 63 divided by p squared. So I want you to do that first. The square root of 63 divided by p squared. So it's kind of like another one, like number 9. I just want to do that one more time. So according to the quotient rule, that would be the square root of 63 divided by the square root of p squared. And then 63 is not a perfect square, but is there a perfect square that goes into 63? So in other words, can I simplify the square root of 63? Yes, because 9 goes into 63. So I get the square root of 9 times, what's that, 7, is that right? Okay, and so by the product rule, this becomes the square root of 9 times the square root of 7, and the square root of 9 is 3, so you got 3 squared is 7. So that's your numerator. And remember, we're assuming that all variables represent positive numbers only, and so we don't have to worry about absolute value, and we also don't have to worry about the fact that p cannot be 0 here because my denominator would be 0. Okay, so what's the square root of p squared? P is even. 2 divided by 2 is 1 because p times p is p squared. All right, so there's your answer. All right, let's look at number 11. Number 11, this time we're going to talk about that square root of 16x. All right, so number 11, we have the square root of 16x divided by y to the 16th. Okay? All right, so first of all, use the quotient rule. Use the quotient rule first. So I get the square root of 16x divided by the square root of y to the 16th. Okay? Now look at the numerator. Let's look at the numerator. If this is all you had, let's say forget about all this. If this is what you had and you're asked to simplify this, what rule would you use next? The product rule. So this would be the square root of 16 times the square root of x, right? And then can I simplify the square root of 16? Yes, 16 is a perfect square. What's the square root of 16? 4. Can I simplify the square root of x? No, because the exponent is 1 and 1 is less than 2. So you're done. So the numerator is 4 square root of x. Okay, now let's talk about the denominator. Think about the denominator. Is this the easy kind? Yes. Why? Because the exponent is even and my index is 2. 2 is an even number. So what's 16 divided by 2? 8. So it makes sense. It makes sense that the square root of y to the 16th is y to the 8th because y to the 8th times y to the 8th is y to the 16th. So this becomes y to the 8th. And so there's your answer. Okay. Number 12, I have the square root of 10x squared divided by y to the 18th. 10x squared divided by y to the 18th. All right, so again, that same idea. So I'm going to use a quotient rule first. Quotient rule first. So I get the square root of 10x squared divided by the square root of y to the 18th, right? So let's go off to the side and deal with the numerators, just like we did here. So the square root of 10x squared, using the product rule, becomes the square root of 10 times the square root of x squared. Can I simplify that square root of 10? No, because the only perfect square that goes into 10 is 1. So that's going to say the square root of 10. What's the square root of x squared? Is that the easy kind? Yes, because 2 is even. So what's the square root of x squared? It's just x. So we get, in the numerator, we get the square root of 10 times x. Now be careful. Don't make it look, so this is an error that some students make. So be careful. Don't make it look like this. Okay, because that looks like x is is part of the radicand, and it's not. What's the only radicand here? 10. Okay, so be careful. Don't do this. And so now the denominator, so 18 is even, so that's the easy kind. What's the square root of y to the 18th? Y to the 9th. So you can leave your answer like this. Now, remember we said earlier that we tend to sometimes rewrite it to where the square root's on the end if you have a variable, and that's because of this issue here. So if you want to, you can say x square root of 10 divided by y to the 9th. Does not matter. Okay? Does not matter. Okay, number 13, we have the square root of 88 divided by x to the 14th. The square root of 88 divided by x to the 14th. Okay, according to the quotient rule, use the quotient rule first, I get the square root of 88 divided by the square root of x to the 14th, right? Let's talk about the square root of 88. Is there a perfect square that goes into 88 besides 1? All right, well, what about 4? Okay, so let's see, 88 divided by 4. 88 divided by 4 equals 22. And is there another perfect square that goes into 22 besides 1? No, because that's 2 times 11, right? So it's only 4, so 4 is the largest. So this will become the square root of 4 times 22. Okay, 4 times 22. And then using the product rule, this is the square root of 4 times the square root of 22. The square root of 4 is 2, so you get 2 square root of 22. So that's your numerator. So your numerator is 2 square root of 22. Okay, so again, always when there are no variables involved, definitely put the square root in the end. And then this is even, so what's the square root of x to the 14th? It's just x to the 7th. Because x to the 7th times x to the 7th is x to the 14th. Okay? All right, 14. Let's do one more. So let's be number 14. The square root of 600 divided by y to the 32nd. That's 32. So y to the 32nd power. So it's kind of like number 13. I just want to do an extra one like number 13. So according to the quotient rule first, you get the square root of 600 divided by the square root of y to the 32nd. Okay? And then let's go off to the side and talk about the square root of 600. Is there a perfect square other than 1 that goes into 600? Yeah, 100. So it'll be the square root of 100 times 6. And 100 is the largest because besides 1, there's no other perfect square that goes into 6. So this becomes the square root of 100, the product rule, times the square root of 6, and the square root of 100 is 10, so you get 10 square root of 6. And so that's your numerator. So your numerator is 10 square root of 6. The denominator, that's the easy kind because 32 is even. So what's 32 divided by 2? 16. So that's y to the 16th. Kind of makes sense because y to the 16th times y to the 16th, when you multiply like bases, add exponents, that's y to the 32nd, which was the radicand. And so there's your answer. Okay, so in this lesson, that's where we started talking about, when we talked about simplifying radicals containing variables, that's where, for the most part, some of our variables had odd exponents, okay, and you had to simplify this using some ideas from previous lessons, from previous courses also. All right, so this is the lesson. on simplifying radicals containing variables.